Yo, yo, yo! What's up, everybody? Welcome back. Today we're working on our window manager yet again. This is him. Look at this bad boy. He's running right now in a window in our normal window manager. Very exciting. We don't need the VM for testing anymore. And here is a quick little demo app, right? So we have a window that is loaded. He's rendering some background. He's fading in and out of red so that we can tell which parts are the background and which parts are windows. We have, our GUI demo app that has a couple graphs rendered in the center of this thing. You might notice that this looks nothing like a normal window manager because we haven't implemented any of the features yet, right? So, if you look closely here, this looks fucked, right? Because we are not respecting the size of the buffer that was passed in. We are just kind of scaling this thing to match our window size and being like, we'll put it dead center in the middle at 50%, which is wrong, right? Windows have sizes, they have positions. We want to draw like borders on this thing, maybe write down the title, have a way to close it, right? There's all sorts of stuff that we want to do here. And so today is about starting to work towards that a little bit. We've kind of knocked off the like low level details of, passing buffers where they gotta go. We have the data we need to render. We just want to render it a little bit better now, right? So the plan is let's start by like respecting the size that the client asked for. Let's try to render this thing at the correct scale. We probably then want to add a little window border to this thing and then maybe be able to like click and drag that window border to like position the window here. Then we can finally see two windows at once because we'll be able to take them away from sitting on top of each other. Then maybe we'll add a little close button to that thing, hit test it with the mouse, see what happens. See what happens. But yeah, let's just start like moving and grooving and see what happens. Okay, so we have to figure out where the fuck does the window size come from? I don't know if I like know that right now. Like we kind of have like a file descriptor that has a buffer somewhere. We do have that. So where does that like what information do we have associated with that? Kind of overall system design is kind of like this. We have some like state. We call this compositor state. The idea is that each Wayland app will kind of like create its own little connection to our guy, right? App, right? We have all these. And each of these has like their own internal state to manage Wayland chatter. But these will all inject surfaces into this state. So the idea here is that in a separate area, we have like our renderer, right? And this guy will kind of iterate over what's in our state and just render it, right? So this state needs to get window sizes somehow, right? He doesn't have that right now, but he does get buffers right now. So we might want to look at that. So I think that we hold renderables in our compositor state. And he is doing what? Somehow this guy gets a render buffer injected. So we kind of have push renderable here and swap buffer. Okay, so probably when we inject this renderable, it means that we have all the information that we want. So this happens on Wayland surface commit, where I don't really remember how these things are tied together. There are, if I remember correctly, there are surfaces, and surfaces have roles. So I think that we kind of represent our window as a surface with the top level role, if I remember correctly. That sounds familiar. Let's kind of like glance at the surface definition. Do you think there's a way to display them with a TUI mode instead, like a minimal effort? It sounds like a 3M kind of idea. Oh, this is like I was mad. Someone beat me to this joke. I can't remember what it's called. There was like a Hacker News post. Wayland in terminal. Term everything. The answer is yes. I think it is not that hard and doable, but someone's already done it. This is a good bit. I've had this on my to-do list for a while, but this guy actually did it. So very doable. Very doable, for sure. Okay. So this surface. A surface is a rectangular area that may be displayed on 0 or more outputs and shown any number of times at the compositor's discretion. They can present WL buffers, receive user input, and define a local coordinate system. Okay, so this is like very much sounds kind of like a window, but like kind of like a more abstract idea of window, right? This is just a thing you can interact with and will show stuff. The size of a surface and relative positions on it are described in surface local coordinates, which may differ from the buffer coordinates of the pixel content. Jesus Christ. Okay, we're not looking at that, and we will ignore that. We will pretend we didn't read that for now. A surface with a role is fairly useless. A compositor does not know where, when, or how to present it. The role is the purpose of the WL surface. Examples of a role are a cursor for a pointer, a drag icon, a subsurface. Oh, interesting. Interesting. So when I'm doing like, when I have like a two like file browsers open, and I try to like, you know, copy something from one to another, this cursor, this is like a drag surface that's being thrown around, I guess, right? This like little preview under the cursor. It's like something like that. A surface can have only one role at a time. Initially, it does not have a role. Once a surface is given a role, it's permanently set for the lifetime of the surface object. Given this current role again is allowed unless explicitly forbidden by the relevant interface spec. Okay, so I believe that the idea of a window is actually not defined in the core Wayland spec. I believe that we are using XDG shell spec to define that. So I think that we assign things a top level role. So I think you have here somewhere, you have like you bind an XDG surface to a Wayland surface. And this XDG surface is something else. What does he provide? It provides a base set of functionality required to construct user interface elements requiring management by the compositor, such as top-level windows, menus, etc. Ah, right. So if I'm in like Firefox here and I have these drop-downs, these are maybe like, these can leave the bounds of the window, right? And so this actually becomes a completely different surface than the window itself, I guess, is kind of what's being shown here, what they're talking about. Right, so this is kind of like get pop-up or get top level. A role must be assigned before any other requests are made to that XDG surface object. So XDG surface, they can be pop-ups or top levels is kind of what it looks like based off this spec. And I guess like a pop-up is a short-lived thing. He doesn't really have like a title. He just has a couple APIs in him, where get top level is like the more interesting thing. So I assume that the top level, we have like resize on this top level thing. What I'm not really like 100% sure on right now is, okay, so we have XDG top level, we have XDG surface, right? And we have Wayland surface. And all three of these things are our window. Right, so the question is like, who defines the size of this thing? You know what I mean? So we can look at XG top level. He does have like a resize thing on him. Starts an interactive resize. Ah, okay, so this starts an interactive resize, but doesn't necessarily set the size of the window directly. He says, I would like to do a resize on this thing. Okay. We do have set window geometry on the surface itself. So when maintaining a position, the compositor should treat the XY coordinate of the window geometry as the top left corner of the window. Interesting. So they were talking earlier about like surface local coordinates. It sounds like this XY is in like window, or like in like window manager coordinates. Once the geometry of the surface is set, it is not possible to unset it and will remain the same until set window geometry is called again, even if a new subsurface or buffer is attached. Sure. If never set, the value is the full bounds of the surface, including any subs or... Oh, wait, hold on. Oh. Is this more like... Is this for like, I have a WLAN surface that is attached to like a WLAN buffer. So these are like GPU buffers. This is kind of also attached to the surface, if I remember correctly. It's like WLAN buffer here. This is like, it actually has like the data being displayed. So I think that you might have like a big ass buffer, and they might be kind of saying like, it could be that you're kind of looking at like a view into this buffer. That might be what they're talking about here, right? Might not be. Not really, I'm not sure yet. Yeah, the arguments are given in surface local coordinate space of the WL surface associated with this XCG surface. That makes it really sound like this is for like kind of like clamping in on a bigger surface. When applied, the effective window geometry will be the set window geometry clamped blah 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 blah. So this guy does indeed set the width and height. So there's one possible place where this is set. Is the XCG surface width height from set window geometry? Maybe. Let's see what other things we might have. I guess something else we could do also is we could look at what happens when we connect to this thing. So we go to main here, and we could set like log scope levels, and we could add a scope to WLAN connection. And we can set the level to debug, and this should give us this should list us all IO on this connection. So when I like start the window manager, we can then kind of like attach our demo app, and we can kind of look at what he talked about here, right? Okay, he rendered a lot in that short amount of time. Okay, here we go. So somewhere we're looking for this 800 by 600 here. So I think we looked at this before, where he sets a region. Then somewhere we tell him like, hey, heads up, like we don't give a fuck. You pick your size. So we sent him a like 00 somewhere, if I remember correctly. And then because we sent him 00, he comes back, and I think I just saw a set window geometry in here. Here. Set window geometry 800 by 600. And set window geometry 800 by 600. Set window geometry 800 by 600. So he's kind of like spamming that shit. Then eventually, he also creates buffers that are 800 by 600 as well, right? Create immediate here for buffers. Can I just look at... Okay, I want to run this again. Kind of spit all the output into a file. Run our demo app. Close it, close this, and can we look for 800 here? Just for some clues. So set window geometry, set window geometry, set window geometry, and then a bunch of buffer creations. So it feels to me like set window geometry is indeed the place, right? So we'll start there. We'll start there where XGG surface is going to be called, and we're going to see eventually set window geometry. And presumably we're going to like get this surface. And we're going to be like, surely we just shove this shit in there, right? This goes into our surface abstraction. And yeah, he must hold like width and height or something. Okay, I don't know. Something like that. And so when we get this thing, we call like surface width is equal to params width. Okay. Now, this has not made it into our compositor state yet. And I don't think it should at this point, because we don't know. I guess this could be called anytime. So we're kind of missing something. You know what? I'm starting to lean towards not needing this right this second. I'm starting to lean that way because the other thing that we are seeing here is that the buffer that comes in also has a size. So maybe the correct place to do this is when we swap buffers into the compositor state. That feels like where this is supposed to happen. And so probably what will happen eventually is if they do this like scoping of the buffer into like a smaller segment, we will apply that at that point. But we don't need that right this second. So we won't do it this second. So I think somewhere we must have like WL surface commit here, and we swap this buffer in. And it seems to me like here is where we would pay attention to the size of this thing, because we know that that came in. Right? We saw this in, if we look for 800 here, we do see eventually these buffers come in with sizes. And these are in pixel space, or pixel coordinates, I guess, which is good. So is this like a thing that we just have right now that weren't looking at? Render buffer. Oh, we do. We have width and height here. Oh, this is easy then. This is easy. In our compositor state, or in our rendering segment, all we have to do is fucking look at that. So when we render these things, here we iterate over all of our renderable things, and we just have to set up our transform relative to the correct answer, like this thing. So we have like each of these buffers. Yeah, we have width here in pixels, height pixels here, and we need to convert these into like OpenGL coordinates. So we need to look at these relative to our size. Do we have that somewhere? Who owns that information? That must be come from like the display backend or something. It must come from our like DRM render backend. Do we have a function on here that's like current resolution? Who calls this? Who calls this? This is only called one time on init. So we don't support, I guess like what would happen is you would go into the like display settings here. Right? And in here, you would like choose a drop down here, and this would trigger a change of that size, right? So I think we can assume for now that the compositor state has an up-to-date view of this thing. You know, so we can call this like a window width or like a display width here. So if we look at this thing, we must have like compositor res. Yes. Yes. Okay. So now we just need to normalize these things, right? So we say width like clip space is the width in pixels over the compositor res width times 2. So this needs to be an F32. It's easier to do this way, where we say like float from int width px width clip times equals 2, and then width clip divide equals float from int on compositor res width. Okay. Now we take this shit and we move it into a function here that's like a, you know, pix to GL to clip, I guess. So this is, you know, pixel here, axis size or whatever. I don't know, something like this. And he returns an F32, and this is, everywhere we say pix, we turn into this. We say clip is this. Okay, and then this is the axis size. And then we can pix to clip here. Like this. Height clip is 1 minus because it's upside down in clip space. Okay. This is I-32, I guess. Whatever, that's fine. Okay, and then we use these for the scale, right? So, oh. I think that this is not normalized, actually. We want this, normalized. So no 2.0. No 2.0, if I remember, and this is just like this. Yeah. Which is just like, that's fine. That's fine. So I think we just shove this in here, right? Sounds kind of right. Height picks. Yeah, we did just not use these. Hello, hello. So if we run this guy now. Oh, it is upside down, so. There we go. Oopsies. Oopsies. Demo. There we go. That looks much better, right? The text here now looks kind of reasonable because we're rendering this at the correct resolution. Which is sick. Which is sick. Okay, the question is, do we want to do positioning or border first? I think border first is more natural. So for each surface that we draw, we're kind of assuming right now that every surface is a window, which is not necessarily going to be true in the future. But we can kind of tackle that when it comes, right? So eventually, we're going to have to support like right-click pop-ups, and those should not have window borders. But we can probably like add like an attribute on the surface for if it needs window borders or not. So let's quickly think about this, right? We have a couple options here. One is we draw our, this is like the buffer that is being displayed by the guy who asked for stuff. Then we need to draw this window border, right? And it kind of needs to look like this. You know, he's going to have like some text in here and an X button over there. So we could render these 4 quads or something manually. Or we could just render one big box. And the only thing we have to make sure of is if we render one big box, we want to draw the surface, this surface first, so that the fragment shader for this stuff, like we don't re-render all of those pixels twice, right? Because my understanding of GPU rendering is that like hand wavy rendering the fragment running the fragment shader for every pixel is like the slow part, right? So if you were to like do that over and over and over and over again, it would be much slower than if you managed to do like depth sorting first and make sure that you're only rendering, you know, huge chunks of the image once. That's my understanding. So as long as we just draw it behind, we're kind of chill. So I would be down to try that. And then the next question is what do we draw here? Right, so we are going to be drawing many pieces of this thing, probably, right? We are going to be drawing like the title, the X, and the border. For now, maybe we just draw the border. This border needs to have like a defined size and location, right? So we probably want to go from like surface to, we want to like convert the surface size to the window size, probably. Right, so maybe in renderables, someone needs to define this thing, and I assume that this thing needs to live in the compositor state somehow, right? Because when we do input handling later, we're gonna want to like click on this border, and we're gonna want to hit test that thing, right? So this doesn't belong in the renderer. It feels like it belongs in compositor state somehow, and it could be that this like renderables concept turns into like windows or surfaces or something. For now, we will like allow the name to stay renderables, but we'll throw a fix me on here that's like maybe renderables should be called surfaces, because when we do input handlings, it's no longer like each renderable. It's like each surface, right? Maybe. On this thing, we have a renderable, and can we just like maybe here we say like window bounds, like yeah, let's maybe on here we probably want like sorry, I'm just thinking. We probably want the like surface bounds, maybe something like this, right? And I think that we want the like window bounds to be on top of this thing. Not going to just do client side decoration for now. Yeah, well, I don't think so. I don't think so. I prefer server side decorations for myself, so might as well work that way. So for now, our surface bounds are like hack all windows are centered at 0, 0, smile. We'll fix that later. So this guy has a width, height. I like using U31s here because it allows us to turn these into I32s easily, and we're never gonna need something bigger than a U31. So this is like a trick I do sometimes. And then can we use like, I feel like storing center X and center Y here is just what's going to make sense. For now. And these should be allowed to be negative. This is just how I feel like it's going to make sense, but maybe we'll change our mind later. So this is easy, right? This is like CX is 0, CY is 0. Our width is oh, you know what? I'm having second thoughts here because on the title bar, this we're gonna have to like keep we need to know like the center of this as well vertically, right? So that we know how to like position the X and the text in this thing. We kind of want to center them in the vertical section here. So, you know, the idea of the center of this window being like not the center of the buffer, right? This is like center of buffer. Center of window would be here if that's how we represented this. So I kind of think I don't want to do it that way, actually. Right? It does kind of feel like this is a relevant piece here. So our window bounds, it's almost like we want to, this is our like origin for the window. And we want to keep track of maybe the like up and down offsets separately. I guess it's like this space is one thing, and then we have like additional space this way is kind of what we want, right? Yeah. So maybe we don't even do this surface bounds thing right now. So window border, maybe we call this. He's not just an arbitrary pixel bounding box. We'll say this is the like title bar CX and CY. So that gives us this point. We're gonna say title bar. I think that the title bar height is probably fixed. So we're gonna just like say that this thing's like, I don't know, 10 pixels tall for now. We can tune this later. And then we need the like surface height here, right? Okay. So center of the top border. Okay. And then we can like, when we render this thing, what are we gonna do then? So for hit testing, this makes sense, right? So we can hit test this box really easily with this because this is this center, this height, this width, which we have from the surface width. I guess like, you know, other border, you know, resize border width or something, like other border size, something like this. I don't know yet. And so my gut says that for rendering, we render the like this edge, this edge, this edge as like one render call, one big quad, and then we render this quad separately. That seems reasonable. That seems reasonable, right? So we kind of, yeah, I like that. I like that. Which means that what we really want from this thing is we kind of want like title quad, right? Maybe pixel quad is what we want here. I don't know. Sure. That feels kind of right. And then we have like, I don't know what like the like other border feels wrong. I don't know like what the word is for that. I need a word for typical can we ask the idiot? Maybe he's got an idea. I'm looking for a name for borders of a window that are not the title bar. i.e. left, bottom, and right all have something in common. I just don't have a name for it. Client, content, trim. Oh, I like trim. Trim's nice. Chrome is another good one. He said Chrome. I do like trim though from Striped Monkey. Yeah, let's get this. Window trim. Yeah, I like that. Okay, cool. This is probably public. And then here we have CX, CY, width, and height. Okay. Beautiful. Border and padding are also good. Thank you for the name suggestions. Okay, so here we have CX's title bar. CX, CY is title bar CY. The width is surface width plus 2 times trim size. Right? Easy. And this is surface height. No. Height is just the title bar height. Easy. And then the window trim is... Here we probably need the, like, surface center as well, right? And so now our window trim is just this. It's surface CX here. Surface center Y here. Width is going to be this as again, and then the height is 2 times trim size as well. So this we will draw a little bit over on the top, but as long as we render this after the title bar, then it's fine. Then it's fine. We are eventually gonna have to do like depth sorting of the windows as well, but we'll figure that out in a minute. Okay, So this guy now is gonna, we want like, I think it makes more sense to do it this way. So from renderable, yeah. Okay. So technically, the title bar CX and CY are calculatable based off the surface CX and CY, right? So we don't need to store that twice. Yeah. So surface CY. The center X is just the surface center X. But this is a little harder to calculate. So this is like the surface center Y minus title bar height over 2 minus the surface height over 2. Right? I think that's right. I think that's right. And this is title bar CY. Oops. Perfect. Perfect. Okay. So now this should be pretty easy. This is 0 for now. Windows don't move yet. LOL. And these are supposed to be in pixel space, right? So this is relative to center of screen is an easier unit for this for now. Especially like in OpenGL space, that's also easier just to manage it that way. How do you decide whether a function is from renderable or to window border? It's just like who seems like they should own it, right? So like window border knowing that he works on a renderable just in my head feels nicer than a renderable knowing that he creates window borders. It's just like I don't know why. I can't like articulate it well. It just feels that way to me. And that's probably like an intuition thing based off of just programming a lot. That would be my guess. That would be my guess. I assume that this width can never be negative. I don't know why it's stored as an integer. Probably because that's what the Linux API is looking for. Okay. Yeah, okay, that all feels relatively okay. So in our rendering section now, can we render those things? I want these guys to have depth values, which this image renderer doesn't really have, which is maybe a problem. Because this was originally written for like my image editor, which was kind of using like 2D transforms everywhere. Can we, okay. Can we just render this at a depth? Is that like a thing that we can do here? Uniform. We don't want this on the fragment shader. We want this on the vertex shader. So I would love to have here uniform float depth or something. I think we throw depth in here. And then we'll just set this to 0 by default. And then somewhere that gets put in some structure somewhere. And now it should be easier for us to override that if we feel like it. Should be. Render texture. And then we'll, because other people use this right now, we'll be like render texture at depth. I just feel like that's easier. Okay. Which allows us here to be like at depth here. So we will render the surface at, you know, depth 0. And eventually we are going to have to account for window order here, right? And so I'm writing this now because I'm going to specify the like window depth as like 0.1, or the like this is going to be like the trim depth is 0.1, and the title bar depth is 0.2 or something. Maybe the other way around, right? Just to avoid the overdraw. I guess the title bar depth could technically be at 0 as well. So it's just the trim depth needs to be like a little bit in. But the reason I'm saying this because I want to offset it. If these things are floats, we can kind of have like their indexes as we can just like cast the depth order into a float for the depth, and then between windows kind of use sub integer numbers for ordering or something like that, right? That's kind of what I'm thinking right now. So I think the easy thing to do here is just do image render is wrong here actually for our thing. So we actually didn't need to do this. We can, well, we kind of want like a solid color renderer, which I'm sure is something that we have. Right, we have like render XYT program, solid color program. This is like a thing we've done before. And I think we want to give this guy like a similar treatment where he takes in a depth. And we allow this guy to... Whoa. I guess it's like this? I don't know, we'll see. We will see... Solid color renderer is solid color renderer. Which feels like he lives here. I don't know. Not really thinking too hard about it right now. Renderer. Maybe this is going to get more advanced later, but for now, solid color is fine. Like this. We pull this thing from here. Boom. Okay. What is this? Oh, like this. Okay. Cool. So now we should be able to slap that border on here. Probably. We're supposed to have some sort of buffer that we're rendering. So we need some sort of like quad. Do you mean to do like the float depth of uniform? I think so. I think I did. Because I think that this is going to be like fed in. Not as part of the like, I think I'm like rendering 2D objects at a depth. You know what I mean? So like the window in the solid color shader. Yeah, I think that I did that on purpose. In my head, it's like, so like the solid color renderer is kind of like he can render arbitrary points at any location, like in 2D, right? And then I'm kind of saying like, okay, now let's like layer this thing in depth, but that's not like, you know, each vertex here doesn't need to have its own depth info. That's kind of like an external third thing that was like, hey, we're gonna have one depth for the whole thing. Was kind of what I was thinking. You know, because I think that a lot of this stuff is kind of designed to be 2D for other contexts. I hope that makes sense. But I mean, I'm not thinking that hard, so that might be a bad choice. Might be. Okay. So I guess we need some like quad to render. I saw float depth without the uniform. Oh, I see. My bad. Did I fuck that up? I was moving quick. Yeah, you're right. You are right. I always assumed that I did the right thing. And so slows, you know, there I'm like, yeah, of course I meant to do what I meant to do. Okay. So this guy needs some sort of quad. So what do we usually do here? It's like full screen quad is going to be I don't know if this is like a thing that we support automatically off this guy. Sometimes we have a function that like automatically generates those guys. Let's see if we have one of those. It's fine. So how do we fucking make a render thing here? Render source, buffer. We make a buffer and then a render source. Okay. So we need to initialize this thing with this allocator. And we're like, give me some fucking x of -1, y of -1. Let's see, clockwise coordinates 2 triangles. So it's gonna be kind of like this. First one we do -1, then we go +1 y to go to the top left, then we want to go top right. And then the second quad is going to be bottom left to top right immediately to bottom right. Oops, there we go. Yep. Okay, and then const full screen quad render source is render source initialized with this guy, and we like set the data according, you know, we say these things probably have to be tried. Bind data for this program. So this is the install call renderer, and we're like, give me this fucking data. Cool. Okay. I think that's close to being right. No field. Is it X pause maybe? I don't remember. Our elements are what? V pause. So it's kind of more like this. Oopies. Okay, how do we generically reset this? It's this is dot v pause equals delete this, find the dot y, delete that, find the comma, and put another one of these guys. Oops, I forgot the equals. So probably something like that. Yeah, there we go. Okay. Oopsies. Okay, he's mad because he wants a program handle. Sure. Sure, something like this. And then we put this somewhere. Full screen quad is a full screen quad render source here. Okay, and then we put this somewhere. Full screen quad XYT program render source. Okay, cool. So now we should be able to just fucking slap that shit here. Right, and we do need our transform here. So this is like probably like this, you know, scope the transform for this guy, and then we're gonna make another transform for this guy down here. I don't know, man. We're fucking clicking. Is this the latest Zig 015.1? Well, I think the latest is 015.2, but yes, it is 015.1. Okay, so I guess it's kind of like this. Boom. This is now going to be the trim quad is maybe window border doesn't live in compositor state. It's feeling like this belongs somewhere else. Split into own file, maybe? Not sure. It doesn't feel like it belongs in compositor state, though, when I'm using it like this. This feels wrong. But, you know, we'll get there. Is this failable? No. Oh, so this is not the trim quad. This is the window border, right? And so then we have the trim quad is window border trim. And then it looks like we probably want like, you know, we probably want like full screen, like quad transform maybe. Which again, this is a wrong spot for this as well. Needs to go somewhere else. And this is going to return transform. Can't wait to see the new async implement. Yeah, it looks pretty good so far. I'm pretty into it. We need the like compositor res here as well. So this is where does he define this thing? Rendering resolution. Okay. So this guy's going to take the quad. He's going to take the CX. He's going to create a transform where he starts by resizing, I think. Probably. Then do the offset, right? But this offset needs to be in GL space. So it's like pix to clip. This is going to be like return pix to norm times 2. Yeah. Okay. Pix to clip here with compositor res width, and then pix to clip here of quad center Y offset relative to the height. Okay, that's easy. Then we just need to inject the scale here, which is pix to norm width relative to the width. Yep, easy. Easy. Okay. So now it's easy to assign the things that we want to do, right? So it's like quad transform trim quad, bing bang boom, easy. All right, and then are we missing some stuff here? Okay, so then he's mad because expected 2 arguments, found 1. Am I crazy? Oh, quad transform here. Okay. Now what's this guy mad about? Color? Can we just make him like really fucking ugly? For now? Make it fucking like bright ass blue? Maybe yellow? And does he want Vec 3 maybe? Yeah, he does. No alpha. No alpha. Which maybe we should support later, but... What's this guy pissed about? I don't understand. Expected one argument, found two. Is it pix to clip, pix to clip? Oh. This needs to be, I mean, it's the transform needs to be a translation, of course. He can't just figure out that I just shoved two numbers at him. He's like, yeah, sure. Alright. I guess we can just see what this does. We want depth here at 0.1. Right, underneath the window. Okay. So if we bring this guy in, what happens? Bad news bears. Other way. Oopsies. Do we have depth testing off? Is that why? We might have depth testing off. Yeah. We probably have an example of this somewhere. Maybe in the client example, maybe? Yep. And we probably need to clear the depth as well. Somewhere. And I don't know if our, like, GBM buffer has, like, a depth buffer in it. I sure hope it does. But if it doesn't, we might have to do some work there as well. So here we need to ask to clear depth as well. GL depth buffer bit? Okay, and then we need to set the... I don't know if we're supposed to be setting this to 0 or what. What is our GL less? Is our GL depth function that we copy pasted? I don't remember which way that means though. Passes if the incoming value is less, so closer to us is smaller. 0 is like in our face, which means that we want this thing to be initialized to infinity. All right. Okay, so let's see what happens now. I think we put the depth negative there because we were flipping things around. There we go. Look at that. That is a window with a fucking yellow border, baby. Look at that shit. That good yellow border. Fucking hot dog theme. Look at that shit. Okay. So this is, we'll call this window border trim, and then we'll kind of move on to title now, right? Okay. So this should be pretty fucking easy, right? So we want to render... That's a lot of ketchup. Well, yeah, we like ketchup around here. Actually, mayo's the thing. When I was a kid, I used to just like eat spoonfuls of mayo out of the container, which is insane, I know. But it started because my mom would make sandwiches and she would like spread the mayonnaise on the bread, and then just to like clean off the knife, she would just wipe the knife on the side of the plate. And so I was like, I like would eat that. And I was like, that's the best part of bread. That's the best part. And so then it devolved into me eating mayo out of the fucking container. But then like it also devolved to using food coloring, right? So I would have just like green food colored mayo, and I would eat so much of it that like my shit changed color. And so then I was like, Mom, my shit's blue. And she's like, you have to stop eating so much food coloring. You have to. And I was like, okay. Why are you dotting me? This is a normal story to tell on a programming stream. This is a normal part of growing up, surely. Surely. What are we doing? We're drawing like the fucking title bar? Okay. So this should be like almost the same, right? We're just doing like the title bar quad, and then like the rest is like the fucking same. It's probably like that, right? Wrong side. Wrong side, huh? Because the quad transform, his Y's need to be inverted. Yep. It's like this. Y needs to be inverted because OpenGL space is upside fucking down. There we go. And then this needs to be like taller. It's too small. It is too small. So title bar height here, 30. Oh, there we go. Look at that. Look at that. Yeah, I used to sit in front of the TV and eat mayo right from the jar myself. That's totally not at all insane. Such that it started to ruin my bowels. Yeah, he gets it. He agrees. I ate some beets and ended up shitting red. I was scared until I realized because of beets. Yeah, that's a terrifying one. I feel like that happens to everyone. Where you're like, oh my god, I have to go to the doctor right fucking now. And you're like, oh, we just ate too many beets. So then you're like, then it's scary to eat beets at all. Because you're like, what if it's hiding cancer, you know? Window, title bar, and shit. Is there a way that I could put this in a YouTube, like, a YouTube chapter? Because you can't say and shit, and poo, and crap. There we go. Probably crap's allowed, right? Surely. Okay. So now we have to hit test this thing, right? So we want to move this thing around by when I click on this. Oh, also the cursor needs to be rendered above everything. We're not doing that right now. We're not doing that right now because we turned on depth testing. And so now the cursor is like, what the fuck? So I think, where the fuck is that happening? Rendering cursor. Oh. This was useful. There we go. That looks a little better. I am concerned that you can like noticeably, I don't know if you guys can tell this, but you can noticeably see the cursor in the window lag. Which means that like this is like it's noticeably behind, which is bad, but we'll fix it later. Okay, so we need to hit test that thing on click. So probably we have like cursor, you know, when debug mode, yeah, I guess there's a real chance that that's the problem, right? It could also be that we're just like behind. And is that Q? No, not anymore. Just a raw Wayland window. So how do I want to do this? We have this like global compositor state, right? I don't think that like input might not be the thing that we want to handle here. We might not want to track like mouse down directly, right? We might want to track uh like some sort of like selection, right? So if I click, we have like one action that we could be doing at a time with the cursor, probably, right? There's like moving, but there's also like resizing, and we can only be doing one of those two things, right? So my gut says we want something like like uh you know, like drag state or something. My GUI toolkit is like 2,000 times slower than debug. I haven't wouldn't read into it yet, especially given how trivial it is to check. Yeah, that's fair. That's fair. Drag state. So what am I looking at here? It's like something like this, probably. And so we have like you know, moving window. And this is going to have probably the like renderable ID. You know, which one he's moving. Right? Something like this. And then we probably have like resizing. And then there's like none, right? Probably something like this. And then we probably want like a notify mouse down thing that happens here. And he is going to assume that we are just at wherever we're at, right? So here we need to like hit test each of the renderable borders, right? So we're gonna go like renderables iter. Oh, we also have to update reorder logic. So what this handle is like an index into a linear array, kind of, almost. And we kind of have like support for like a callback when we reorder this thing to update stuff. And so we just have to make sure we update drag state if we ever reorder those things, because we do occasionally to like reduce holes or free memory and stuff. Like sometimes we need to slide them around. So we just need to like remember to update that. Okay, so we have each renderable. And here we're gonna do something like we want like the window border from renderable, right? Something like this. Yep. And then we want to get the like title quad, right? And we want to check if we are in there, right? So if self cursor pause x, ooh, cursor position is relative to the top left, I think. I'm actually not sure. We need to log the cursor position real quick. I guess we can tell pretty easily by looking at the rendering code, actually. We can just look. So when he renders the cursor, is it relative top left or what? Render cursor. He's relative to the top left, I think. Negatives are hard. So that makes it seem like the CX value for the quad should be relative to the top left as well for like the units to make sense here. I think that's better. So can we just fix this quad transform here? We need to offset this blah, 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 so we normalize this thing, multiply it by 2, and then offset it by the... So this is like... Center is axis size over 2 or something. Then we are trying to put ourselves relative to the center, so we just have to subtract or add center here. One of the two. It's probably like this, right? Because this way it'll be negative if pixel is 0, positive pixel is positive. And then we flip it for y. So I think everything's fine. I think. Which means that when we generate these quads, we need to pass in the, like, resolution. Not sure, it just feels like that somehow. Because our center X, I guess it's more like this. Here. Right, something like this. Okay. Before we do this, let's just make sure that everything works the way it was before. Because we've done something wrong. Uh, whatever. These int casts are code smell, but we can deal with that later. Values specified with geoclear depth are clamped in the range 0 to 1, a minor thing, but that might influence the architecture of how you assign things. Oh, interesting. Good thought. I thought that it was -1 to 1 because clip space, but okay, so this is upside down again, but everything else is close. That's confusing. I don't understand why that is the case. But it is. So I'm not going to think about it any more than I have just now. Because I'm pretty sure that we are doing it correctly in pixel space. But I should, I guess, just quadruple check that. Because height here, like the CY is the surface center minus. Yeah, we're going down. Okay. I won't think about it. But maybe I should. Okay, so while we hit test these things, right? So we will say, like, if cursor pause x is like, there's like stood math between? No, all right. You know, val a b. Return val is greater than or equal to a, and val is less than or equal to b. If between x is between title quad left and title quad right, and you know, the same shit below, but with y, between title quad top, title quad bottom. I'm assuming for now that these are going to be sorted by their depth, which is not true yet because we don't respect window positioning at all, but surely in the future we will. So here, I guess we just like break. And drag state is equal to moving window with this renderable render anvil. Dude, I'm typing like crazy today. All right. Cool. Seems pretty reasonable. That compiled. I guess because this function is never called, so it's not being compiled at all, so there's nothing to check. Let's just say for now, std debug print dragging window, and we will log the handle. Okay. Let's just see what happens here. We did fucking hide the output. Oopsies, fuck. Demo here, okay. We're spamming, which makes this hard. Can we fucking stop it, please? We're still spamming. Unhandle, this is just because we're not looking at WO surface. Let's just fucking ignore that damage function. And then that spam will stop and we can fucking see what's happening. Okay. Nothing is happening. I mean, we're not we never call that function. We actually already talked about this. We actually already talked about this. If self window mouse 1 update notify mouse 1. Maybe we want to do this. I think that feels a little better, right? So here we will do notify mouse 1 pressed. And if it's not pressed, we just clear the drag state. Otherwise, it is pressed and we have some work to do. All right. Cool. We don't have these quad left, right, top, bottoms, but those are easy to make. This is minus self width over 2. Right is plus. Maybe we should be doing some like integer truncating on one side, but I'm lazy, so we won't yet. But I think that might come up later. Might. Okay, now what's he pissed about? F32, found I32. Fine. Fine. If you're gonna fucking be like that, we'll fucking type float from int. I hate implicit casting and I hate explicit casting. I hate them both. I hate explicit casting less, but still go fuck yourself. You know? Duck file? Looks like it. Oopsies. Okay. So if I click any of these, is this clicking here? Drag window, drag window, drag window, drag window, drag window. Hype. Cool. So now we actually have to do the window drag, right? So here, this has got to be like on cursor movement. I guess it makes more sense for us to implement movement and position directly in terms of each other so that we can do all of the like dragging logic here. Also, we probably need to write down like the last position here, right? So we probably need to like last here as a cursor pause so that we know how much to move later. I like Jai's XX, just fucking do it. It's explicit but conveys how you feel. Yeah, that does seem kind of nice. Although it brings back some of the problems with implicit casting where you like change a type somewhere and like it implicit casts somewhere you didn't expect and that causes problems. So kind of, but maybe not. In particular, jail clear death infinity might be misleading. Yeah, I cataloged that in my head but didn't say it out loud because I didn't care enough. But I did appreciate the note, and I should have explicitly said that part because you were taking your time to give me information. Yeah, you're right. You're right. Okay. So now we need like last here is going to be self cursor pause. Boom. And now when we do a movement, I guess we will do this in cursor position. So can we be like here, when we see a movement, we take the current position and we just add, you know, the dx and dy here. Then we don't have to do the clamp here because the clamp's down here. And then this is where we do dragging. So we switch on self drag state. And if we are dragging, moving window, Params, I guess. I don't really give a fuck. Params, like this. Maybe like this. We kind of say, like, we get the renderables. Do we have, like, I guess, storage get at params hand ID? I guess this is renderable. And now we kind of have a problem where this thing needs to own his, like, position. Right, so do we want to stash this as center or what? It doesn't really matter, probably. I feel like it's easier to initialize center X and center Y. But we'll see. Because now here I can just write like... no, I mean... gross. How does this work? So when we push this thing, we construct the renderable on the fly here. But here we don't have the compositor resolution easily available, but that's okay if we just move this a layer up. So here, when we push a new renderable, we will do it from the compositor state. And this will return a renderables handle. And now we have the stuff we need to set to CX and CY. So this is like self compositor res width over 2 and Y is height over 2. Easy. That means that somebody is going to get mad because that push function has been deleted. So this is now push renderable like this. Okay. We're getting a little... Sure. I think that this guy's mad, what, about an int cast? Yeah. Okay. Bing, bang, boom. And now when we create our window border from renderable, we can take this from renderable CX and CY here. Easy. Resolution feels like it's no longer required here because the renderables have taken that into account. Let's just make sure that this kind of all works the way we expect still. Cool. And now we just have to do the drag part, right? So if we like look at this renderable and we have like our offset is, you know, cursor X minus this. This is the X offs. Y offs is the same but Y. And then we're like renderable CX plus equals X offs. I guess we don't even have to do that. We can just do it like this. Boom. Renderable CY plus equals this. Boom. Easy, dude. Easy. This is float. This is float. What's this about? Expected I32. Oh, okay. So I think it's fine. I don't really know why Wayland represents the mouse position as a float, but it always looks like integer positions when I look at it, so I'm not really too worried about us like losing like sub-pixel movements. You know what I mean? Okay, so that did something. We forgot to clear the drag offset. So it kind of just like ripped off the screen there, right? X is backwards, but Y is not? That's not good. Yeah, something seems really fucking wrong. Something seems wrong here. I'm gonna log this. Renderable CX, renderable CY. It's just something is not correct here. In like a way that doesn't really make a lot of sense. So here, the logged values of X and Y are quite large here. And quite, oh wait, hold on. Yeah, so if I'm like taking from the center, we get X quite low. Yeah, okay. So the values seem right to me here. It's the rendering that's broken. So like, what the fuck is going on here? I guess like this. Okay, better. But now the surface needs to come with it, right? Which is not happening yet. So we render this thing for each renderable. Um, we have to I guess we want like the surface bounds. Is there this like a quad transform? Here we go. Here we go. This is what we're looking for. So this is our pixel quad needs these parameters. So cx is item dot cx, cy is item cy, width is items. It's probably like a little bit more val here. Buffer width, here we go. That seems right. Maybe some int casts. Okay. Maybe you need to make a tiling window manager like God intended. I don't really. Oops, we flipped something that we shouldn't have. Oh, is that where we fucked up? Why? Whoa. What is going on here? Ah. We were supposed to flip the height here on the scale, and we forgot before, which was causing other problems. Oopies. Is this all correct now? Negatives are hard, man. Close again. Y translation is all upside down. There we go. Look at that shit. Easy. Easy. Okay, so now what happens if I show two windows? Oh, come on, man. Come on. We're losing release events, I feel like. I don't really know when. It feels like sometimes it's getting stuck in the drag state. But maybe I'm just making that up and I'm oh yeah, here. My mouse is my fingers are off the mouse, right? But it's still dragging, so that's interesting. It's if I is it if it happens it feels like it's like if I click and drag quickly. Like if I click very quickly here, it's okay, but if I click and drag with a fast click, we lose it. Yeah, I'm not quite sure what's happening there, but uh let's fix it. Why didn't we fix this log, by the way? Oh. Okay, let's try this again. Okay, so demo. Okay, yeah. So let's do this. We did window positioning. Let's do uh fix stuck dragging. Cool, sick. Let's go Pog. Hell yeah. Thanks guys. It is pretty sick. I got distracted by the breakage, but it is pretty fucking cool. We should take some time to appreciate that. Okay, so the question is, why are we dropping fucking release events? It feels like this is right now. This is not where it's supposed to be. But you know, we have mouse one update. Oh, it's like if we go down and up in a single frame. Yeah, it's probably like we need an input queue because what's happening is we only get the latest thing. I think. Okay, let's see. So I'm acting like I know, but I don't know. I'm just guessing. But if we were to take a guess, it would be that somewhere in our window abstraction, we have mouse one update. And here we're trying to say, like, okay, std debug print, button changed, and let's put down the button state. And then can we also say pointer update like this? If there was an input event, I guess. We'll call this a button update. And what I'm expecting to see here is that we see both events from Wayland, but not here, right here we're seeing it, that same state, that same problem. So we see that he's getting two updates within a single frame, and he's dropping them, and that's annoying. Okay. So this input events thing needs to be some form of queue, right? It's the only thing that makes sense. So this could be what? We have like a pointer movement. Which is a pointer pause. And then we have mouse one down. We can actually separate these now if we want, right? We can do mouse down, mouse up. Yep. And then here, our pending input events is, I guess both of these are just like circular buffers. That seems reasonable. You know, something like this. And we probably, when we swap from pending to input, we probably like just swap the backing data or something. We probably, I don't know. We'll figure it out. We'll figure it out. These things I think can't be default initialized anymore. And, ooh, this guy doesn't depend on stud right now. All right. I guess the window manager is like using old allocation style, old system. We haven't updated yet. So I guess in this world it's okay for this to be array list of input event. I guess. And maybe yeah, maybe that's fine. Hey, hey. Boom, 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 boom. I don't know. I don't know. Maybe this was here. Fuck it. Fuck it. Fuck it. Boom, 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 boom. And we have input events and pending input events here. And what do we do? On deinit, we have to deinit these things. Like this. Bing, bang, boom. This guy is going to on service. When he gets this thing, he's going to be like, pointer update is input event. Hello? Pointer movement. Like this. And we're gonna be like self pending input events append pointer update. Cool. And then we have a button update. Mouse one update is input event. Mouse one down. I guess okay, it's like this. If this we get input event mouse one down. Nope. If param switch on params state or something, and if it's like 0, it's input event mouse one up. And this is mouse one down. Bing, bing, boom. We get like event is here. And then we do pending input events append this event. Have you been following recent Stod.io changes? I'm looking forward to async, curious to see how you'll use it. Yeah, I mean, I saw that talk from the talk / page from Andrew. I think I like it. I think. We'll see. I don't really know. I need to look at how they're going to implement their async stuff. Because if they do some of that like crazy stackless coroutine stuff, that would be cool, but I don't think is what I want necessarily. I'd have to think about it a lot. I think like I'm scared of the magic that goes on to make that work. I like magic is a strong word. I understand how it works. It's just to me the idea of how do I say this? I found writing async Rust that you need to create a mental model of a state machine in your head to correctly use these awaitable things, right? And so to me it feels like just writing the state machine is better. So if they end up making like an automatic coroutine thing, I might not use it. I might implement my own. Not really sure though. We'll see. We'll see. Why? What is this guy pissed about? Event shadows. Oh, I see. But we will see. Okay. So now what is happening here? He's what is he pissed about? Oh, this shit again. Dude, is there so this like is an enum of the input event where if I do this, it like resolves the type correctly to the union of the input event. Is this always feels like kind of wonky to me? How am I supposed to not accidentally use the enum? Like, I would think that if I call input event.mouse up, I should get the fucking union field, no? Because the thing is a union? Yeah, this always feels kind of strange to me. Because, like, it's crazy to me that saying, like, I want input event.mouse up, and that's, like, not the thing I want. But if I put colon input event here, then it is the thing I want? Something about this always feels kind of wonky, but the only thing that's right now is the async API with thread pool or block backing or an IOU backing. Right. Okay, that makes both of those make sense. I agree. Yeah, those I saw those APIs and those look great to me. Like they look like what I would want. Or at least from usage, I'm guessing what is under the hood is probably what I want. But I haven't looked at their input yet. Input events. Okay. Okay, so this thing needs to, when we commit the pending events, this is wrong now. I think we actually want to std_mem swap these guys. Right, so we're kind of like double buffering these. You know? And then we can say self pending clear. I think that's kind of correct. I think that's allowed. So now when we're looking for pointer updates, we're like, this needs to be like for window input events, switch on event, if it's a mouse, pointer update. In this client, we are just logging. So this kind of moves up like this. And this is more like this. Mouse, what pointer movement. And then mouse one down. We log mouse pressed. And then on mouse one up, we log mouse released. Wowza. Okay, so this is our like example. Wonderful. And then this is also going to be broken in our actual usage of this in the fucking window manager. So here we go for self window input events, event. We switch on the event. I guess the switch can come out. That's kind of nicer, right? Then it's like pointer movement is this. Mouse one down is this guy. Oopsies. And then I like these should be fix me rename to notify mouse down and up. That's nicer to me. To me. All right, let's see if that works a little better now. Let's see, demo. Interesting. It's still happening. That's way more confusing. Wow, that's way more confusing. Hold on. Is it backwards? Hold on. Down. Whoa, okay, it's still happening. So that's not the problem, maybe? Which is surprising. Um... Why then? Std debug print button received input. Okay, and then can we look at in the compositor state? You know, notify mouse one, notified input pressed. Demo, okay. Okay, okay, there we go. Okay, here we go. Okay, here, so he did receive input 0, but not notified input false. That's confusing. Confusing. Which means that this input events iterator is not reflecting that. Oh, we're kind of exiting this loop early sometimes. Yeah, but this would only be on window close. I guess like so on service we clear the input events. I'm confused. I'm confused. How is this coming in here? We slap this into pending input events. Then we see this frame happen. Hold on. Yeah, okay. Yeah, it's weird. It's weird. Because I guess this service function might not be called. No, it has to be called. If service is called, then it's happened. Std debug print iterating input events. Let's look here and see if this gives us any information. Oops. It does not because it's gonna log spam. I guess like if self window input events len is greater than 0, maybe this is a little easier to reason about. Oh, but movement counts as well. How confusing. How confusing. Frame committed. Let's see if this gives me any clues. Oh. Oh, that's annoying too. There's so much log spam if we do it this way. Well, also, what the fuck was that? That looks broken. That's so strange. So strange. Um. It's like it's just getting like fully lost, man. It's just, but how? We put it in pending input events. On frame, we clear pending input events after swapping it into normal input events. And then we iterate the input events. And then we clear input events every service loop. It could be this somehow. I just don't understand how, because I would think that every service, every time we service this thing, we should iterate over all of the input events that we collected. And the input events might not have got them all, but we would get them on the, like, they haven't been swapped in from pending yet, so it should be fine. Is there a loop here that I'm missing? Oh, yeah, we are swapping in multiple times. So we don't want to swap here, we want to append slice. I see. It's self input events, append slice from self pending input events items. Then we clear the pending input events. Because we might have multiple, this is coming in like multiple packets within one service call. It's something like that. We forgot the allocator probably. Yeah, that's a little better. I think that we can't hit that failure case anymore. Yeah. That feels better. Feels better to me. Okay, so we have this, and then we have Swayland client. Oopsies, wrong. Here we go. Boom! Look at that! Isn't it beautiful? Isn't it beautiful? We need to fix like ordering, window ordering, but this is pretty good for now. Cool. That takes us to 4 o'clock, which is right right on the edge of where we want to, time we want to spend on this stuff per day. So I think we call it there. Thanks for watching, guys. If you like what we saw, we stream most days. We aim for 12:30 to 4 o'clock Pacific time. It is 4 o'clock Pacific time now, so anywhere between 3.5 hours ago and now if you're watching live. There's a YouTube link in the Twitch description where, a good chunk of this stuff goes up. Most like feature development goes there. Some other stuff does not go there. So today we were doing like a bunch of like cleanup, kind of like things that are not really titleable and thumbnailable, or I'm like too stressed to figure out how to like package it, that stuff ends up in Patreon or YouTube members or in Twitch VODs. If you support in the appropriate place, you could access the rest, but you don't really need to follow, you don't need all that to follow along. So it's kind of like a nice to have. Also, you get the knowledge of knowing that you're supporting the stream, because one day I probably will run out of money and we'll have to get a job, and that day I will stop streaming. But until then, we do this. Whoa, what the fuck was that? He just freaked out. Anyways, I think that's all I got to plug. Thanks for watching. YouTube, peace out, and Twitch, let's find someone to raid.